this video, we're going to go over how to do the procedural to find the name of basic alkanes, right? So I know it's a basic video, but it's the foundation, right? And maybe I'll build onto this video as we go on. Right, so what's the first thing that you need to do? Well, the first thing that you need to do is find out which is going to be the longest chain in the molecule, which one is going to have, the parent name, etc. And so I usually count from right to left. So let's do this. We have 1, 2, 3, 4, 5, 6, 7. Okay, so that's 7. But what if you're not sure about yourself? What about if you did this? 1, 2, 3, 4, 5, 6, 7. We did that. Would that be okay? Well, yeah, actually there's the same thing. There's the same thing. If you did 1, 2, 3, 4, 5, 6, and 7, notice how, like the blue one would have this ethyl group and the blue one would also have a methyl group. The same thing happens. In the red group, we have an ethyl and a methyl. Now you're probably wondering what the ethyl is or what a methyl is. Well, an ethyl, or we'll start with methyl. Methyl is actually, it's a derivative, or it's a brother or sibling of methane, right? And let's say that we want to bond. So we want to bond to our parent. So we're going to get rid of this hydrogen, and instead of having, like a hydrogen there, we're going to be connected to a carbon that is connected to some other molecule. And so really we just rip off a carbon and connect it, we rip off a hydrogen, and we connect that little sibling to the parent. And that sibling has, for basicness, right, if you're just starting off, it's going to have like a "-il" suffix, right? And so when we say ethyl, it's a derivative of ethane, but we rip off like some hydrogens, right? And we're going to connect it to the parent. Now, we've recognized that this is going to have 7, right? It's going to have 7 groups, or 7 carbons. And if it's 7, you know that it's going to be heptane. So on an exam, it might be, this is hexane, or, the answer choice could have hexane, pentane, etc. But maybe one of the questions or the answers is heptane, so you don't have to do any work, right? That'd be cool. All right. Now, I've realized that this molecule is a heptane. All right, what do? I have to find the number that gives me the lowest substituent. So I have to find kind of like the lowest number that my substituents can be on. And by the way, substituents is just like it's a fancy word to say group. And I like to think of it in this way. I like to say, we're naming the family. We're naming a parent chain. If it's a parent chain, then it's going to have children. And those children are actually called the substituents. Right. Okay. So that means that whenever we're participating in nomenclature, we're actually just naming families. And that's very cute. I like that. All right. So what is this? This is the methyl, right? And what is this? That's an ethyl, right? Okay, but where are they located? Are they located at 1, 2, 3, 4, 5? Is this 5? Well, no, it's not 5 because, I could count it left to right. This is 1, 2, 3. And I'd rather have my children on, like a number 3 than a number 5 because my children are the highest priority. They get like the best thing ever. I don't want them to get like, this is like the 5th best toy in America. No, I want them to be like, this is the best toy in America. I want them to have the best of everything. So I want them to be on the lowest number, closest to 1. That's ideal. Everything they do has to be number 1. So that's bad parroting, but it's good for memorizing. So we're going to say that this is a 3. That this is a 3, right? And what do? Notice how I just I recognized my parent chain, right? And then I found out where my children are going to be at, what number, and then I'm going to combine them. Well, actually, I labeled my children, so I gave them names. So now I'm going to collect my children and their location, and I'm going to put them with the parent. Okay. Usually when you do this, it's going to be a location. We're going to call that a locant. You know, child, locant, child, etc., and then parent. Locant, again, is just the location. Child is going to be your substituent. And, of course, whenever you get in trouble, your parent usually says your full name, right? And they say in, like, alphabetical order or by age. But in this case, we're going to say alphabetical order. So, according to the alphabet, last time I checked, back in, like, 13 years ago, E comes before M. So we will say that this is a 3. Now we're going to get my child, Ethel, and we're going to look at the location again. 3. Look at my child, methyl. Do we have another location? No. So we're going to drop that location and we're just going to say the parent. So we're going to say, oh, this is heptane, so it should be heptane. So we have a 3-ethyl, 3-methyl-heptane. And remember to put your hyphens, right? Remember to put your hyphens. Because in your last name, if you had hyphens, you're going to get mad at someone who doesn't hyphenate your name, right? It's very offensive. So first we're going to name our parent chain, then we're going to name our children, and then we're going to find out what number our children are, or where they are. Then we're going to collect them, bring them to the parent, and then what? We're going to name them. Very simple. Let's do some more practice. Okay, so in this family, what do? Well, we got to name our longest chain. So this looks pretty long. We could do 1, 2, 3, 4, 5. Let's see here. 1, 2, 3, 4, 5, 6. Yes, so 6. 1, 2, 3, 4, 5, and 6. All right. If you did the other way, you would have 1, 2, 3, 4, 5. And that's not good. And over here you would have 1, 2, 3, 4. Right? We're counting 1, 2, 3, and 4. So going this way would give me the longest chain. And of course, this comes with practice. I highly recommend that you look online for practice problems. So that's 6. Alright? And now we have to realize that if that's our chain, then these are going to be children. So that's a child too. Alright, and this is a methyl, and that's a methyl too. Methyl you could just recognize by a single line. They're like the most simplest thing, right? So a line is pretty simple. Okay, so what location are they going to be in? Are they going to be in 1, 2, 3, 4? Is it like that? Or is it like 1, 2, and 3? Well, it's going to be 3 because my children are going to be closer to 1, and that's where I want them to be. You see? That's a good parenting, kind of. So, we're going to have 3. But do we do 3 methyl, 3 methyl, what is this, hexane? Yeah? Well, that's kind of redundant and my hand hurts from writing, so I don't want that. Instead, if you have 2 of the same things attached to the same carbon, you can say 3, comma, 3, dash. Now, how many methyls do we have? 1 and 2. So we can say di, which stands for 2, right? And we're just going to put methyl. We're going to put the child's name. Methyl hexane. Whoa, that's super scary. Not really. If we follow the same procedure, it's going to be the same thing. It's going to be really simple. Okay, so I mean, just kind of eyeballing it, you kind of want to like lean towards the left, right? And go right here. See here? It's okay if you cut through some carbons. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9's a pretty high number, and I don't think we're gonna beat that. Let's see. 1, 2, 3, 4, 5, 6, 7. Not good. 1, 2, 3, 4, 5, 6, 7. Not good. So realize that normally you start at like a terminal carbon, right? So you kind of have like 4 real possibilities to count from. So if you feel overwhelmed, just count from like the edge and go inwards, okay? Of course, you're not going to be like, oh, that, because it doesn't take into consideration the whole molecule. All right. So we said that we're going to do this, right? And it's a nonane. Okay, so nonane. And nonane is just 9 carbons, right? So we wanted our children to be on the lowest carbon number, but we got to name our children first. So this is a methyl. This is a 1,2 ethyl. And 1, 2, 3, 4. 4. That means that this is 5. 1, 2, 3, 4, 5. If I went from left to right, this would actually be number 6, and that's pretty bad because 4 compared to 6, 4 is lower. It's closer to 1, and that's what we want to do. That's where we want to be at. So we're going to say that this is actually 4-methyl, and we have a 5-ethyl. And we have the parent name, and we're good to go. Let's do it. Alphabetically, E comes before M, so we're going to say 5-ethyl, 4-methyl, nonane. Notice that the numbers don't matter. Like 5 and 4, they don't matter. It's all about alphabetical order, alright? In the simplest terms. Alright, so how do we do this one? Well, as usual, let's kind of count our families. Well, let's start from here. It's 1, 2, 3, 4, 5, 6, 7, 8. 8. That's pretty big. Like that's a pretty good number, pretty high. But what about if we did this? 1, 2, 3, 4, 5, 6, 7. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Excuse me, 8. What if we did that? Because like they're both the same number, 8, and that's pretty good. So I'm conflicted. I'm really conflicted. Well, let's do the dark blue and green. So this represents the dark blue. Okay. If we did the dark blue, then we would have 1, 2, 3 children, right? We would have 3 children. And if you have the same number of carbons on each potential parent, well, the tiebreaker then is going to be how many children you have. Right. So if we did the light blue one, which is going to be in pink, we would have 1, 2, 3, 4. That would be 4 children. And so I'm going to pick this number. I'm going to pick going left to right. Okay, so we're going from left to right. Let's name our children. This is the methyl. Right here, here, and there. Those are just like lines. But what about this one? Let's see. 1, 2, 3. This does not count. 1, 2, and 3. 1, 2, and 3. And usually it goes like M, E, P. So that's 1, 2, 3 carbons. This is a methyl, ethyl, and propyl. Alright, so methyl, ethyl, propyl. We have 3 carbons, propyl. So this is going to be a propyl. After that, we're going to name, or we're going to find the number that we want our children to be on. So let's see. Actually, it would be great going to the right, right? Because then we would have a 2 compared to a 3, right? And we want the 2 better than the 3. So this is a 2-methyl. This is a 4-methyl. 6. And this is a 5. 1, 2, 3, 4, 5, and 6. Okay, so we're gonna bring these kids together. We're going to put them with their parent and name them off, right? We're going to name them. All right. So we're going to say that this is a what? First, we're going to name them 2-methyl, 4-methyl, and then a 6-methyl. And to be honest, this is kind of redundant, so we're just going to say 2, 4, 6 methyl. Okay. Well, now we have a 5-propyl. And as you know, numbers don't count, so where do we put this? Well, let's see. LMNOP. M comes before P. LMNOP. Okay, so alphabetically, we're going to put M before propyl because it's the alphabet. So I have 2,4,6 methyl. Let's put another dash. 5 dash propyl. See, locant, right? Location, child, location, child. Do we have another location? No. Do we have another child? No. So we have all our children. We know all their locations. We're going to put them back with their parent. So 2,4,6 methyl 5-propyl. And what is this? 1, 2, 3, 4, 5, 6, 7. So that's a heptane. 2,4,6 methyl 5-propyl heptane. Very, very classy. Now that we got naming alkanes down, simple alkanes, we can move on to branched substituents or branched children. So some of the few famous ones that you're going to be encountering in organic chemistry, they're going to be mainly like the butyls, right? So we're going to be dealing with butyl. And butyl is what? 4, right? Because you have methane, ethane, propane, and then you have butane. But if you were to take off a hydrogen from that butane, you would actually get a butyl, so we can connect it to a parent chain. So a butyl is going to have 4 carbons. Right there, this carbon is kind of like what I just drew right there. That's just like a symbol that represents that we tore off a hydrogen from that carbon. So that carbon has 2 hydrogens instead of 3, right? If you want me to extend this image, we have hydrogen right there, a hydrogen, and it could be bonded to another carbon that goes off with its parent, right? So that's a butyl. But you should also be familiar with isobutyl. Isobutyl. So what's an isobutyl? Well, normally when you think of iso, think of a Y shape. Think of a Y shape. So we have a Y, that's 1, 2, 3 carbons. 1, 2, 3 carbons. Alright? And they're attached to another carbon. So 1, 2, 3, 4. 4 is butane, but since it's connected to a parent chain, it's going to be butyl. So isobutyl. And this carbon is kind of like, is going to be connected to its parent chain. So we're going to just denote it like that, right? It's just a squiggly line to show that it can be connected. So that's isobutyl. Alright? And then we're going to have sec-butyl. Sec-butyl. And it looks like this. Now it's called sec-butyl because you have 4 carbons as usual, but the butyl substituent is actually connected to the parent chain via the second carbon. It's via the second carbon. You can also be connected this way, but usually you're going to see it like this. So this is going to be the second carbon that's connected. So that's a sec-butyl. Look out for those when you're looking at complicated molecules, complicated structures. The final one is pretty easy to remember. It's very distinctive the way it's drawn. Usually you'll see it on an exam. So it straight up looks like a T, right? It looks like a T. So 1, 2, 3, 4. Well, actually, yeah. The middle carbon is actually connected to the parent chain, right? So this one does not mean that there's 5 right there. That doesn't count. It's just is to show that this carbon is the one that's being connected. So in total you would have 1, 2, 3, and 4. Or if you want a better picture, it looks like C, C, another one, that one, right? If that makes it feel better. So it's called a tert-butyl because it's going to be connected on what? The tertiary carbon, like the third one. The third carbon, sorry. And, I mean, if you want like a mnemonic device, a tert-butyl kind of looks like a T, right? It looks like a T. Okay, alright. So it's important for you to know that when you're naming these kind of substituents, that you will use iso, the letter I in isobutyl, alphabetically. And you're going to be using the B in sec-butyl alphabetically. And I forgot to write this down. That's a tert-butyl. When you're writing this down, you're going to have tert-butyl, okay? And you're going to be using the B right here for tert-butyl. So those are going to be alphabetically when you're naming these substituents. Alright, so isobutyl has a Y shape, sec-butyl kind of has like a Z shape, right? And you're going to be connected to the second carbon, that's why it's called sec-butyl hyphen. And tert-butyl is on the third carbon, and you're going to be using butyl, butyl, and iso for the naming part. Alright, so in this molecule we have to name it. We're going to have to name this molecule. Okay, so the first thing I want to do is just write out the longest chain, which you should be familiar of doing. It's going to be this one. It's going to be that one. Now you're probably going to notice that we have a weird branching thing hanging off of us. So what is that? Well, my friend, that is called a tert-butyl. A tert-butyl. And yeah, sometimes it's not going to be drawn as nicely. Normally you want it to be drawn like this, right? We have 1, 2, 3, and 4, right? But sometimes it's not drawn as nicely. Sometimes it's like a Y-ish shape, like a peace sign, right? So if you see like a peace sign, it's most likely a tert-butyl. Okay. So we identified our longest chain. That's 1, 2, 3, 4, 5, 6, 7. It's going to be 7. And when you're naming these, you're going to have to follow the normal procedure. So we want to have our child on the lowest number. So let's see if we can do that. 1, 2, 3, 4. That's going to be 4. 1, 2, 3, 4. Well, going from left or right, I'm always going to be 4. So that's fine with me. I know that this is going to be 4. And that this is a tert-butyl. So we're going to say tert-butyl. Okay. So how do we put this together? Well, of course, you're going to have location first, so 4. Then your child, tert, include the hyphen, butyl. And then you're just going to have how many substituents you have, so, or how many carbons are in the chain. So 1, 2, 3, 4, 5, 6, 7. So that would be 4 tert-butyl heptane. Now, on the exam, there might be another answer choice. Let's say that you have 4 tert-butyl heptane, but on the exam it might show up as 4 dash 1 dimethyl ethane octane. And these are completely equivalent. It's a bit flamboyant, it's a bit pompous, but it's just something you gotta memorize, right? We have 1,1-dimethyl ethane for, tert-butyl. So tert-butyl can also be called 1,1-dimethyl ethane, and it just comes with practice a lot of the times. Like, I can't really explain why you would call it dimethyl ethane. It just doesn't make sense for me for tert-butyl, but hey, it's just practice, right? Alright, for this molecule, our longest chain is going to be this one. And that means that this is going to be our child. Okay, so which one is that? Is that an isopropyl, a tert-butyl, a sec-butyl, or just a plain butyl? What is it? Well, actually, it's not even a butyl. If you count it, it's 1, 2, and 3. This doesn't count. So it's 3, so that means it has to be a what? A propyl. Okay? And it's in a Y shape, right? And whenever you think of something that's Y, you gotta think of iso. So we have a propyl and it's a Y shape. Well, that must mean that it's an isopropyl. And indeed, if you said that, you would be right. This is an isopropyl. And what carbon is it on? Is it 1, 2, 3, 4? 1, 2, 3, 4. Going from left or right, it's going to be 4. And since it's 4, we're going to say that this is actually 4. This is our child, isopropyl. If I can spell. 4 isopropyl. Now, how many carbons are on our parent chain? 1, 2, 3, 4, 5, 6, 7. 7. 7 means heptane. So we will say 4 isopropyl heptane. Okay. Isopropyl is actually easier to remember than tert-butyl, right? If tert-butyl is 1,1-dimethyl ethyl somehow. But actually, isopropyl is going to be 4 parentheses with a hyphen 1 methyl ethyl heptane. And actually that does make sense, because let's make this substituent into dots. Let's make that into dots. We have a carbon, another carbon, and another carbon, right? So one carbon is going to be a methyl, and what are the other ones? Methyl, ethyl. So 2 carbons makes an ethyl, 1 carbon makes a methyl. So you can say 1 methyl, and then the other 2 are just going to be ethyl. Right? So we have a methyl right there, and then the next 2 are going to be ethyl. And that makes sense to me, right? We just collected the dots. So 1 methyl ethyl. If you're on the exam and you need for clarification or something quick, you could just say, well, that's a methyl, then that's a methyl ethyl. Right? So it's good to write off both structures, like the names, in both ways. So this could be 4 isopropyl heptane. This could also be 4-1-methyl ethyl heptane. Very pompous, if you ask me. That brings me to another very important group that you should know, and it's called a neopentyl, right? So it's a neopentyl, and the way you can differentiate a neopentyl is that it has 1, 2, 3, 4, 5 carbons. So neo is like 5, right? You can think of it of like, Neo from the Matrix, right? Yeah, it's a very famous scene from the Matrix. This guy starts shooting Neo with like at least 5 bullets, but like Neo does a backflip and he dodges all the bullets. I mean, he doesn't do a backflip, but you know, he does something in slow motion where he dodges the bullets and is like super amazing. So Neo's 5, and 5 corresponds to this molecule, or this substituent. So it's important for you to know that this can also be called 2,2-dimethyl propyl. Dimethylpropyl. Okay? So a neopentyl has 5 carbons. It kind of looks like an arrow, and then it's attached to that, right? So 1, 2, 3, 4, 5. Looks like an arrow pointing to the right, and then it goes downwards. And it can also be called a 2,2-dimethylpropyl. This is a neopentyl. Also, just a quick thing to say, if you ever want to classify hydrogens, you can classify them as follows, right? So this is the carbon on one end. It's going to have 3 hydrogens. And if you want to classify a hydrogen, just treat it like an alcohol. This hydrogen is connected to a carbon, and that carbon is connected to one carbon over here. Therefore, this hydrogen is going to be labeled as a primary hydrogen, because it's connected to a carbon, and that carbon is connected to only one carbon. However, for a carbon that's in the middle, it's going to have 2 hydrogens. Wedge means that it's coming towards you. Hashes means it's going in the back. All right. So for this carbon, it's actually attached to 2 other carbons. And so we can say that both of these hydrogens can be classified as a secondary hydrogen. So when in doubt, just treat it like an alcohol, as you would number alcohols, number a hydrogen similarly. All right. And now we finally begin with the halides. So you have chlorine, you have fluorine, bromine, iodine, right? Well, if they become connected to like a substituent, then you would denote it as, when you're spelling it, you would say chloro, fluoro, bromo, and iodo. Iodo is pretty fun to spell. And yes, this would actually matter when you're alphabetizing, when you're doing nomenclature. So that does matter, the letters. Very important for you to know. And normally they can occur in those weird little groups that I gave you. So for instance, we can have an ethyl chloro or ethyl chloride, right? So ethyl chloride, and that's 1, 2. 2 carbons means that it's an ethane, but since it has something connected to it, it's going to be ethyl. So it's ethyl chloride. We can also have this. And hey, that's a Y, right? So Y, you should be thinking isopropyl. 1, 2, and 3. This one does not count because it's actually going to be bonded to what? Well, let's make something up. Let's say Br. So that's actually isopropyl. And what do we say? Bromide. Okay. And we can also have, let's see. Oh, that's a T, right? That's a T. It looks like a T. So 1, 2, 3, and 4. If you're ever doubtful, just count your carbons. So that's 4. So we can say that it is a what? It is a tert butyl, and we can say bromide, right? And it can also be found. It can also be found in a what? Let's do this in a green. It can also be found in a kind of like a weird one, chloro. And let's see here, 1, 2, 3, 4. So, and it's a Y shape, right? So 1, 2, 3, and 4. 4 carbons, so it's a butane, but it has something connected to it, so it's a butyl. And it has 4, and it's connected in like a Y shape. So you can say that this is actually an isobutyl. Isobutyl what? Chloride. Isobutyl chloride. That's cool. And finally, let's not forget our best friend ever, right? 1, 2, 3, 4, 5, and we're gonna have this. So what is this? It looks like an arrow. It looks like a hand. It's a weird looking thing, but actually, if you count it, 1, 2, 3, 4, 5, it does look like a hand, right? That's pretty cool. So this is a neopentyl bromide. So yes, whenever you have halides, they can actually apply to those little weird groups that I gave you. they can definitely apply to them. And it follows the exact same structure. Neopentyl, you just add a bromine, so bromide. Isopropyl, you add a bromine, bromide. Tert-butyl, you add a bromine, you get bromide. Ethyl, ethyl chloride. Isobutyl, isobutyl chloride. Very simple, you just add the halogen, you get a new name. Pretty cool. Alright, it's very important for you to know. That, well, first of all, this is a pentane that is 5 carbons long, and this is going to be a methyl, and this is going to be a chloro, right? Chloro. Well, it's important for you to know that a halide and a simple alkane, like a methane or a methyl, they're going to have the same priority. Priority means that they're going to have the most importance when you're naming something, right? So, like, let's say you have a favorite child. Well, that child's going to be very important for you, and you're going to try to cater to its needs first than the other children. So if we had alcohol in here, we would try to make it more important. We would do everything we can to satisfy it. But in this case, we have a chlorine, which is a halide, and we also have a methyl, which is just a simple alkane. So when they're combined, they're not very important, so they have the same importance. And because they have the same importance, we just have to number, we have to start numbering the closest to it. So what I mean is, we're not going to start numbering over here, right? Because if we did that, we would say 1, 2, 3, 4, 5, compared to the correct one, which would be 1, 2, 3, 4, 5. Yes, the methyl would still be on the 3rd carbon. However, I'd rather have a number 2 chlorine than a number 4 chlorine, right? So you're really comparing 2 and 3 compared to 4 and 3. So which is closer to 0? Which one has it's closer to 0? I mean, if you were to add these, this would be 5, and if you were to add these, this would be 7. And which one's a less number? 5, right? So I'd rather have a smaller number for my molecule than nothing, right? Than a larger number. So because of that, I'm going to be numbering from left to right. Because they have the same importance, I'm going to be numbering from left to right. So, yeah, just remember that any halide is going to be the same importance as a simple alkane. This is like a single bond. And you just want to have the lowest number possible for your children. So we will say that this is a what? This is going to be 4 chloro. This is a 3 methyl. Alright. I like to separate my children first and then kind of like alphabetize them and then bring them together. So we found the biggest carbon chain. We realized that a halide and a simple alkane are going to have the same equal importance. So we just want the smallest number for both of them. And we're going to name them. Which we did. That's a 4 chloro, and that's a 3 methyl. We separated them, now we're going to bring them back together to the main parent. So which one am I going to do? Well, since they're both important, we're going to name them by alphabet, right? Alphabetical order. So C comes before M. So we're going to say 4 chloro, 3 methyl. Don't ever forget your hyphen. And this is a what? 5 carbon chain. So this is going to be a pentane. Alright, so 4 chloro, 3 methyl pentane. Okay, for this molecule, you can substitute chlorine for bromine or iodine or fluorine. It doesn't matter, it's just an example, right? So notice that if we count our carbon chain, which is 1, 2, 3, 4, 5 carbons long, you'll notice that both chlorine and the methane, or the methyl, are going to be on the 2nd carbon, no matter if you count from left to right. So if you count from left to right, this is going to be 2nd carbon. If you count from right to left, this is going to be on the 2nd carbon. So we have kind of a predicament. But here's a simple way to solve this. Well, this is the chloro, right? And this is going to be a methyl. And so which one comes first? Well, I'm going to say the chloro comes first because it has a C in it. And C comes before M. Because since this is alphabetical, right, we're going to favor the alphabetically first substituent. So instead of counting from right to left, I'm going to say 1, 2, 3, 4, and 5, simply because the letter C in chloro comes before the letter M in methyl. So this will be a 2 chloro 4 methyl pentane. We did that because chloro comes before methyl in the alphabet. So because it comes first in the alphabet, we will count from left to right. We will slightly favor the halide, right?